Here's our third video in the trigonometric unit, angles of elevation and depression. Our goal in this video is to be able to use angles of elevation and depression to solve for unknown values. So this whole video is a review from geometry, but things we need to remember before we can move on in trigonometry. So to start with, what are sine, cosine, and tangent? In words, sine is the opposite side over the hypotenuse. The cosine is the adjacent side over the hypotenuse, and tangent is the opposite side over the adjacent. We remember it by so, ca, toa. So sine is opposite over hypotenuse, so OH. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent, so OA. Example 1 is finding the value of each variable. So we want to find the value of W here. So we're going to use the trig functions. If you remember so, ca, toa, we want to know which of these to use. So if I have the angle 54, 17 is our hypotenuse and W is our opposite side. So if I have opposite and hypotenuse, I want to use sine. So I'm going to use the sine is equal to the opposite over the hypotenuse. So the sine of 54 is equal to the opposite, which is W, over our hypotenuse, which is 17. I'm going to multiply both sides by 17. And we get 17 sine of 54 equals W. Now this is the exact answer, but normally we want a decimal equivalent, so we put that into a calculator. And we get approximately 13.8. In most calculators you could do 17 times sine of 54. In those calculators that are single view, you would do 54, the sine button, and then times 17, so working backwards. The second one, we're going to do the same thing. We have the adjacent and the hypotenuse, because here's our angle. So we're going to use cosine. So the cosine of x is equal to the adjacent side over the hypotenuse, so 15 over 20. To get rid of cosine, we're going to do the inverse cosine because they're opposite operations. And then we get, in a calculator, usually this is the second button, will get us the cosine of -1, and we get 41.4. Now if you don't remember this from geometry, there will be some remedial videos that you can look at that go through trig functions in a little more depth. So we're going to look at some vocabulary. Angles of depression and elevation is the angle formed by a horizontal line, so always a horizontal line, and the line of sight to an object below or above the horizontal line. So this girl has an angle of elevation to the parasailer, and the parasailer has an angle of depression to the girl. Now notice that these two angles are congruent, and if you remember alternate interior angles from geometry, the horizontal lines are parallel. Those would always be the same. So if we ever have the angle of depression, but we need the angle of elevation, and it's between the same two objects, they will always be the same. In this example, they want us to describe the angles shown. So we want to start by describing angle 1, and they show us angle 1 is here. It's below the horizontal line, so it's an angle of depression, looking from the person in the airplane down to the air traffic controller. So it is an angle of depression from the airplane to the air traffic controller. The second one asks us to look at 4. Well, 4 is above the horizontal line, so it's an angle of elevation. And it is from the ground crew up to the air traffic controller. So it is an angle of elevation from the ground crew to the air traffic controller. In this example, they tell us that a rescue worker is located 175 feet above the ground in a lighthouse. He spots a ship on the water at an angle of depression of 62 degrees. How far from the base of the lighthouse is the ship? Round to the nearest foot. So I'm going to make this pretty picture into math. Here we have our worker on the lighthouse, and there's the ship at an angle of depression. Now notice the worker, if he was standing on the lighthouse looking straight out, that would be his horizontal line. and the angle of depression is below that horizontal line at 62 degrees. And we know he's 175 feet above the ground. And we want to find out how far from the base of the lighthouse is the ship. So we're trying to find this horizontal length. Well, 62 does not help me up there. But as we discussed on a couple slides ago, if that angle is 62, this angle also must be 62 because they're alternate interior angles. And I'm trying to find x. From the 62 degrees, 175 is my opposite, and x is my adjacent. So if you remember back to our trig functions, so TOA, if I have opposite and adjacent, I'm looking at tangent. So I'm going to do the tangent of 62 here. So let's move that picture out of our way. And the tangent of 62 will equal the opposite, which was 175, over the adjacent x. Need to get that x off out of the denominator, so I'm going to multiply both sides by x, and I get x times the tangent of 62 is equal to 175. And then I'm going to divide both sides by the tangent of 62. And our exact answer is x equals 175 over tangent of 62. But they asked us to round to the nearest foot. So we're going to put that into a calculator. 175 divided by the tangent of 62. We get approximately 93 feet. So the ship is 93 feet from the base of the lighthouse.